Hi. So we're going to look at the Maclaurin series today in this video. And the most important thing about Maclaurin is that he's actually Scottish, so he's a Scottish mathematician. So what Maclaurin series is a special type of a Taylor series. And I'll define what a Taylor series is. It is the infinite sum of terms that are expressed in terms of the function's derivatives at a single point. Okay? So given a point A, we can have the function, and then its derivative of a function, and then its second derivative with the multiplication of x minus a and divided by the 1 factorial. And then you can hopefully see that it goes f double dashed a x minus a all squared all over 2 factorial. So the next one would be f triple dash a x minus a cubed over 3 factorial, and it would keep going on, hence the infinite sum. Now, the Maclaurin series, although it kind of looks like I've just done Maclaurin, as a C there. The C's and L's look a bit similar. The Maclaurin series is a special case of the Taylor series such that a equals 0, and hopefully you can see that it immediately makes things a lot easier to deal with in terms of the algebra. Okay? So what we can do is we can express functions in these infinite series, which allows us to get approximations of these series up to a certain point. Okay? So it's a really straightforward process, as long as you remember the formula, which you're actually given. Although in the formula sheet it takes it up as far as x to the power 4, I think. But it's the same series, anyway. Yeah, so if I want to take these up to the term in x cubed, like I've said, find the Maclaurin series for the following up to the term in x cubed. So I'm going to need to have at least 4 terms. I'm going to have f of 0, f dash 0, f double dash 0, and f triple dash 0, as that'll be when we first get x cubed. So let's get those derivatives. So for the first one, fairly straightforward. But now all we need to do is get the sum, what they are at f of 0. So you can see for this case, it is very straightforward. E to the power 0 is just going to be 1. And it's the same thing for the next 3 as well. So I can straight away just sub that in and get our formula. And there, and we could have kept going on and on and on and on and on, but it's just going to have the same patterns. Okay, so e to the x is a fairly standard one. There's some expectation that you should memorize this, but really it's actually straightforward, and it's not. There's a lot of effort to memorize it when you can just also very, very quickly work them out. Now let's do a slightly more complicated one, cos x. So you can see the derivative of cos x is negative sin x, and then negative cos x, and then sin x, which then we can substitute in 0 to get. So substituting them all in, cos of 0 is 1, negative sine of 0 is 0, negative cos of 0 is negative 1, and sine of 0 is 0, and so I can get the formula. So you can see here that the 0 multiplies to get rid of the x, and the 0 multiplies to get rid of the x cubed. And since I've only asked to have it up to the term x cubed, then I don't care about any of the other terms. Okay, although it would then be positive x to the power 4 over 4 factorial, and then it would be, it would keep going in a pattern. Okay? So what the most important thing to recognise about these is that we can calculate products of Maclaurin series. So you can see example 3, I'm not going to have to differentiate e to the x cos x and then differentiate that and then differentiate that and then differentiate that, because I've actually got what the Maclaurin series for e to the x is and the Maclaurin series what cos x is. I can just multiply them. So I'll write it in there for a bit more space. I can see that the Maclaurin expansion for e to the x we've got here. And then I've got the Maclaurin expansion for cos x. So it's kind of like double brackets, but it's an infinite series, but we only want it up to the term in x cubed, and now we just multiply out and arrange. I'm going to ignore that term because I've gotten to the point where I'm going to do x squared over 2 factorial times negative x squared over 2 factorial. It's going to give me a power of x to the power 4, which I don't want because I'm only going up as far as term in x to the power 3. And again, x cubed times x squared is just going to give me x to the power 5, so I can ignore it. And now let's arrange. And so rather than me having to calculate out all of the e to the x cos x and then the derivative of that and then the derivative of that and the derivative of that, I can express it very quickly as a sum, as a product of its individual Maclaurin series. Okay? So if you're ever asked to do a complicated one, but you've got individual components which are straightforward, then that would be a quicker way and a better way of doing it. Okay? So that is Maclaurin series.